The wind arrives before the cold. It moves across open land like an invisible blade, stripping warmth from skin, from stone, from breath itself. The sky hangs low and colorless, the ground frozen into iron hardness. In this world, survival is not a matter of comfort. It is a negotiation with physics, with energy, with time. Ancient humans stand small against the immensity of hostile environments. Their bodies, evolved for temperate climates, lose heat continuously to the surrounding air. At -20 degrees Celsius, exposed human skin can begin to freeze in less than 10 minutes. The body radiates warmth through conduction, convection, radiation, and evaporation. Without protection, core temperature falls below 35 degrees Celsius, and hypothermia begins its silent descent toward death. Cold is not merely temperature, it is energy extraction. Wind accelerates this theft. At 40 kilometers per hour, the body loses heat nearly 5 times faster than in still air. Snow reflects sunlight but offers no warmth. Nights stretch long and unforgiving. Fire flickers and fades quickly in open terrain. The human body alone cannot generate enough heat to resist such relentless forces. So humans begin to think like engineers. They observe animals that burrow beneath snow, where temperatures remain stable. They notice how soil holds warmth, how caves resist wind, how the earth itself is not frozen deep below the surface. Beneath 1 meter of ground, temperatures fluctuate slowly, insulated from the violence of weather. The idea of shelter is born not from comfort, but from physics. Reduce heat loss, reduce exposure, conserve energy. Shelter becomes the first machine humanity ever builds. The earliest constructions are simple depressions in the ground, shallow pits lined with branches, hides, and grass. These are not homes in the modern sense. They are thermal barriers.
This is the thickness we agreed
Wind
on. No,
flows
look closer.
over
It's
them rather
significantly
than
less
through
right
them.
here.
The earth absorbs and slowly releases heat. Snow, paradoxically, becomes insulation. Trapped air pockets within snow reduce thermal conductivity, forming a protective shell against deeper cold. In frozen tundra and steppe regions, humans dig deeper. Semi-subterranean dwellings emerge. The entrance tunnels face away from prevailing winds, forcing cold air to settle in lower chambers, while warmer air remains in living spaces. Geometry becomes survival. Circular structures reduce surface area exposed to the outside, minimizing heat loss. Even without formal mathematics, early builders intuitively design according to thermodynamic principles. The physics is simple but powerful. Heat flows from warm to cold, always seeking equilibrium. Humans must slow that flow. Materials matter. Stone stores heat but conducts cold. Wood insulates but burns. Animal hides trap air, reducing convection. Packed earth resists wind. Each component becomes part of a thermal equation balancing heat retention and structural stability. Shelters evolve into complex systems. Walls layered with soil, bones, timber, and fur. Roofs domed to resist wind pressure. Floors elevated slightly above frozen ground to reduce conductive heat loss. But the environment remains merciless. Storms arrive without warning, carrying snow dense enough to bury structures overnight. Ice forms along entrance tunnels, sealing inhabitants inside. Food freezes solid. Water must be melted, costing precious fuel. Every decision becomes an energy calculation. Dig deeper, spend energy. Build thicker walls, spend time. Gather more material, risk exposure. Humans adapt by engineering redundancy. They create multi-layered shelters. Outer barriers break wind. Inner chambers conserve heat. Some structures include airlock entrances, narrow, low tunnels that trap cold air before it enters the living space. These tunnels function like primitive thermal regulators, reducing convective heat loss by up to 60%. Even the act of crawling through them minimizes the exchange of warm interior air with the outside. Underground construction becomes a turning point. Below the frost line, temperature stabilizes near 0 degrees Celsius, far warmer than surface air during extreme winters. Humans carve into hillsides, riverbanks, and frozen soil. Subterranean homes emerge, not as caves of desperation, but as engineered thermal sanctuaries. Earth sheltering reduces wind exposure almost completely. Heat generated by bodies, fire, and animals accumulates instead of dissipating. The home transforms into a controlled climate system. Vent openings are small and carefully positioned. Too large and heat escapes. Too small and smoke suffocates inhabitants. Walls are angled inward to reduce structural collapse from snow load. Roof beams are reinforced with bone and timber, distributing weight across the structure. Everything serves a function. Nothing is accidental. Humans begin to understand that survival is not about fighting nature, but about redirecting its forces. Snow becomes insulation. Earth becomes armor. Geometry becomes defense. Shelter becomes life. Inside these primitive structures, warmth flickers for the first time against the crushing silence of winter. The outside world remains deadly and vast, but within these walls, a fragile equilibrium forms. The body no longer battles the cold alone. Architecture shares the burden. This is the foundation of human survival engineering, the moment when intelligence transforms vulnerability into resilience, when shelter becomes more than protection, when the earth itself becomes an ally against extinction. And winter, once an unstoppable enemy, begins slowly to lose its absolute power. Fire becomes the heart of the shelter. In darkness, in isolation, in endless winter, flame is more than heat. It is life converted into energy, wood into warmth, oxygen into survival. Yet fire is dangerous, unpredictable, and inefficient if uncontrolled. Ancient humans must learn not only to create fire, but to engineer it. An open flame wastes energy. Nearly 80% of its heat escapes upward into smoke. Early humans observe this loss and begin modifying fire placement. Hearths are dug into the ground, surrounded by stones that absorb and radiate heat long after flames fade. This simple design increases thermal retention dramatically, turning brief combustion into prolonged warmth. The shelter becomes a heat engine. Smoke must escape, but heat must remain. Ventilation systems emerge, narrow smoke holes positioned above the hearth, calibrated through trial and error. Too wide, and warmth disappears. Too narrow, and smoke fills the chamber, poisoning lungs with carbon monoxide. Some shelters include angled smoke channels that slow airflow, allowing heat to linger while guiding smoke outward. Firewood becomes a form of stored sunlight. Fuel management becomes critical. In extreme climates, a single night may require 20 to 30 kilograms of wood to maintain survivable temperatures. Humans ration fuel, stack it strategically, and dry it near the hearth to improve combustion efficiency. Wet wood wastes energy evaporating moisture. Dry wood burns hotter and longer. Knowledge of fuel becomes as important as knowledge of shelter. Animals enter the system. Dogs, livestock, and even reindeer share enclosed spaces with humans. Their body heat contributes measurable thermal gain. A single large animal can produce over 500 watts of heat, equivalent to several small fires. In tightly sealed shelters, shared warmth reduces fuel consumption and stabilizes interior temperature. The boundary between human and animal becomes less rigid. Survival is communal, not individual.
Clothing becomes portable shelter. Animal hides, fur layers, and woven fibers trap air, reducing heat transfer through conduction and convection. Multiple layers create thermal gradients, slowing heat loss from the body. The principle mirrors modern insulation. Trapped air resists energy flow. Clothing extends the thermal envelope of the shelter, allowing humans to move outside briefly without catastrophic heat loss. Food becomes fuel for the body. In extreme cold, the human body may require over 4,000 calories per day to maintain core temperature. Fat becomes essential, dense, energy-rich, slow-burning. Hunting systems adapt to prioritize animals with thick fat reserves. Meat is dried, frozen, or smoked for long-term storage. Every calorie is measured against energy expenditure. Waste is minimized. Survival demands efficiency. Daily routines follow the rhythm of energy. Morning begins with rekindling embers preserved overnight beneath ash, a primitive thermal battery storing heat. Fire is fed slowly, not explosively, conserving fuel. Ice is melted into water. Tools are repaired. Clothing is dried near the hearth. Ventilation holes are cleared of frost. Every action maintains the fragile thermal balance of the shelter. Ventilation remains a delicate science. Warm air rises, carrying moisture and smoke. Without proper airflow, condensation forms, freezing into ice along interior walls. Over time, this reduces insulation and increases structural risk. Humans learn to regulate airflow by partially sealing vents during storms and widening them during calm periods. The shelter breathes like a living organism. Efficiency becomes the invisible architect of survival. Sleeping platforms are raised above ground, where air is warmer. Bodies sleep close together, sharing warmth and reducing exposed surface area. Cooking and heating occur in the same hearth, maximizing energy use. Tools are stored near heat to prevent brittleness. Even movement is minimized to conserve calories. Fire, shelter, clothing, food, and animals merge into one integrated survival system. This is engineering without equations, physics without textbooks, knowledge carved into memory through generations of trial, error, and endurance. Failure means death. Success becomes tradition. Outside, winter still dominates the landscape. Storms rage, temperatures plunge, darkness stretches endlessly. But inside, warmth persists. Systems hold. Fire breathes steadily. Humans endure not because they are stronger than nature, but because they have learned to design within its laws. The shelter is no longer just protection. It is a machine of survival. Winter tests more than the body. Tests the mind. Isolation stretches across months. The landscape remains silent, unmoving, endless. Darkness lingers long beyond sunset. Humans confined within shelters face a different enemy, psychological collapse. Survival now depends on meaning, on connection, on belief. Communities form tight social structures. Tasks are shared. Knowledge is distributed. Elders guide, hunters provide, builders maintain, storytellers preserve memory. Cooperation reduces individual burden and increases group resilience. In extreme environments, loneliness can be as lethal as cold. Shared purpose becomes emotional insulation. Firelight becomes a gathering force. Around the hearth, stories emerge of ancestors, of animals, of unseen spirits moving through wind and snow. These narratives are not mere entertainment. They provide structure to chaos, turning unpredictable nature into something understandable. Spiritual beliefs offer psychological stability, reinforcing hope when survival seems uncertain. Winter isolation fosters introspection and discipline. Tools are repaired. Clothing is mended. Shelters are reinforced. Preparation for spring begins long before snow melts. Food stores are monitored, rationed, protected. Seeds, if available, are preserved. Hunting routes are planned. Survival is a cycle. Endure winter, prepare for rebirth. Knowledge transfer becomes sacred. Children observe silently as elders demonstrate fire making, shelter repair, clothing construction, animal tracking. Skills are taught through repetition, not words alone. Every generation inherits engineering refined through centuries of survival.
Secure the planks
Mistakes
tightly.
are remembered.
Roll the hides.
Successes
We
become
leave soon.
tradition. Even architecture carries cultural identity. Different regions evolve distinct shelter forms. Snow domes, earth lodges, hide-covered frames, each optimized for local climate and materials. These structures are not random. They are encoded survival knowledge shaped by environment, passed down through time like living blueprints. Psychological endurance becomes humanity's greatest adaptation. Hope persists even in darkness. Rituals mark passing time.
As the seasons
Songs
turn,
echo against earthen walls. Community bonds strengthen under pressure. Humans discover that survival is not only about heat and food, but about meaning. The belief that winter will end, that life will continue. And spring always comes. Snow softens. Ice fractures. Light returns. Shelters open. Humans step back into a transformed world. The systems that sustain them through darkness now prepare them for renewal. Survival is not a single event. It is continuity across seasons, across generations. The legacy of ancient survival engineering remains alive today. Modern insulation, thermal design, underground architecture, passive heating, all eco principles discovered by early humans facing extreme environments. The idea of a home as a climate-regulating system, of efficiency as survival, of resilience through design. These are ancient truths shaping modern civilization. In the end, survival was never about conquering nature. It was about understanding it. Ancient humans did not defeat winter. They learned its rules, adapted to its physics, and built systems that transformed vulnerability into endurance. Their shelters were not just structures of earth and wood, but living machines, breathing, warming, protecting. And within those fragile walls, humanity learned its greatest lesson. Survival is engineering guided by wisdom, sustained by community, and illuminated by hope.